All right, so we're looking at the z-test for the proportion. This is the last of the one sample hypothesis tests we'll look at. So like we saw before with the confidence intervals for the proportion, just to refresh your memory, P, lowercase p, is the population proportion, and P hat is the sample proportion. And P hat is the point estimate of P. So if we had to pick one number as our best guess for the population proportion, it would be the sample proportion. Don't confuse this with the p-value. That's the number that gets compared to alpha, and that's how we determine the conclusion of a hypothesis test. So we've got p hat, the sample proportion, p, the population proportion. Alright, so we're going to look at how to do hypothesis testing in the section for the population proportion. Just like with the previous two tests we saw, we have three possible sets of hypotheses. These ones are in terms of p and not mu, because we're looking for the population proportion. So the null hypothesis is always p equals some hypothesized value. And then the alternative hypothesis is p less than some hypothesized value, or it might be greater than, or it might be not equal to, depending on the problem. Okay, just like we had before, this less than is the lower-tailed test. This one is the upper-tailed test. Both of these are one-tailed. And then this one, the not equal to case, is the two-tailed. Here's the test statistic. This looks a little messy, but it's not that bad. It's the simple proportion minus the population proportion, the hypothesized value, divided by all of that. And again, we're going to do the same thing we did before of rejecting H naught if the p-value is less than the alpha. So here's an example. We have a sample of 300 women, and we find that 228 of them have ever tried dyeing their hair. And we want to test whether more than 75% of all women have ever dyed their hair. Just like we saw before with the confidence intervals, one way you know that this is a problem for the proportion is that you have x out of n. In this problem, 228 out of 300. Okay. So the alternative hypothesis is going to be p greater than 0.75. Proportion, remember, always has to be between 0 and 1. So we want to convert that to a proportion from a percent to a proportion. So the alternative hypothesis is p greater than 75%. The null hypothesis is p equals 75% or 0.75. The sample proportion, which I'll ask you to figure out, is p hat 228 out of 300, which gives you 0.76. If you plug into that formula, you get 0.4. I'm actually not going to ask you to do that calculation by hand, but it's there if you want to see how it's done. P-values are calculated the same way we did for the other z-test. If we want to find the probability z is greater than 0.4, that's going to be 0.3446. That gave us alpha is 0.05. So that means that the rejection rule is reject H naught if p-value is less than 0.05. Remember, it's always less than. That means because our p-value is not less than 0.05, we fail to reject H naught and say that there is not sufficient evidence to say that more than 75% of all women have ever dyed their hair. Keep in mind, again, we know what the sample proportion is. The sample proportion was 0.76. So we know what that is, but what we want to know is, does that give us enough evidence for that more than 75% of all women? So according to this example, 76% in the sample doesn't give us enough evidence that more than 75% of all of the population has that characteristic. Okay, so I'm not going to make you do those by hand, but that example is there if you want to see it. For this example, I just used StatCrunch. So suppose we took a sample of 200 middle school students and 88 were able to spell the word occurrence correctly. If we use alpha equals 0.05, test to determine whether fewer than half of all students correctly spell the word. Again, we have x out of n, so that tells us it's a proportion, 88 out of 200. They want to test whether fewer than half, so that means our alternative hypothesis is p less than 0.5. From StatCrunch, we get that our test statistic is negative 1.697 and our p-value is 0.0448. Pay attention to the videos and they'll show you how to get those values. And we reject H0 if p-value is less than 0.05, because again, 0.05 is in the problem. In this case, our p-value is less than 0.05, so we would reject H0 and say that there is sufficient evidence to conclude that fewer than half of all middle school students correctly spell the word occurrence. All right. So again, these problems are very easy as long as you know the basics of hypothesis testing and you can do StatCrunch. All right. And as always, let me know if you have any questions.